So if I was to give you a elevation map represented by non-negative integers, where each width of the bar is 1, how much water is there in this graph? So the water would be falling into these troughs or pits, basically. So how would we go about calculating that? So if let's think about this example. So we can obviously see there's an elevation of 1 here and an elevation 2 of here. So therefore, if there was rain, there'd be water between these two blocks at an elevation of 1. If there was 2 blocks here and 3 blocks here, then there would be obviously rainwater falling between the two. And if there's a bar here and a bar here, therefore there would be 4 units of water between these two bars or boundaries. And obviously over here, we've got a section here and a section here and a section underneath. There'd be water be trapped in there. Okay, so the question is, how do we calculate this? And obviously we're given an array, so we want to know, like, how do we go about this? So the first thing you always want to do is think, okay, how would I brute force this? So one brute force solution is that you could maybe find the maximum peak of this entire elevation map. So you could think of it almost like a 2D matrix or a grid, and you could base it like, okay, what we're going to do is we're going to iterate from this top left square, iterate across, and if we find two values, right, like a left boundary and a right boundary, then therefore everything between those boundaries has to be water, basically. And if obviously you only have one boundary, but only one left boundary, say, but no right boundary, then there's no water. So you could basically iterate across this entire grid. So you'd iterate across, say, this row, and you would find no water. Then you would iterate to the next row, right? And in this case, you'd find a left boundary, which is this square, and a right boundary, right? And then you'd find 3 water units between those. And then obviously you'd find a left and a right here, but there's no space in between, so there's no water. And then you'd find a left here and a right here, and then there'd be a water unit there. And then obviously there'd be no right boundary to this empty square, so you'd leave it as is. Then you go to the final row and you basically repeat the same process, and you'd find all the water that way. But the problem is the cost, the time complexity of this would be obviously whatever the max, let's say the maximum peak is m, and let's say the total length of this list, the height list, is n. Therefore, you'd have to go n times m time complexity, which is, it's not great, but it's better than nothing, right? Now, what if we were to somehow get this down to just n? So we iterate over the array once, and then we can do the calculation. So to think about it that way, we know there's some sort of relationship between like a left side, like we know if there's some sort of relationship between like a left and a right, and we can think about it as like, well, what if like we somehow, and we also know that there isn't just going to be one trough or one bucket, basically. We know there could be multiple buckets. So we know there's some sort of relationship here or strategy. So like another idea would be like, what if we found the maximum left peak and the maximum right peak, right? If we were to find the maximum left and right peak, then we know that from the left, if we're descending downwards, that has to be water. And if we're descending down from here, that must be, if we're descending down from the right and we're lower than the left, then there must be some sort of water in between, basically, right? So there's this idea of thinking about it as like a bucket, and you have like a right peak and a left peak. Now, the problem with finding the global maximum right peak and the global left maximum peak is that, well, what do we do about if we calculate the water in this bucket? What about the buckets on the left and right side, right? Now, a naive approach would be like, okay, maybe we can kind of reverse engineer something where, like, if we know the left max peak, we can kind of figure out this or something, right? if we find the max right peak here, we can somehow reverse engineer going this way. But in doing so, you know, it's difficult to know if we can achieve that in n time. So that's the goal, is that we only want to do this in n time. So what we can also do instead is maybe we can maybe we can think of multiple buckets. So instead of just thinking of like a max right and a max left peak, what if we like had we had a max and right peak at that instance of the elevation map, right? So what if we found like a local maximum left and a local maximum right, and then based the calculation off that? So for example, what if we like found we started from position 0 and moved right and check to see if we can find a maximum left at that point in time? So for example, we could find that there is our left max would be 0 at position 0. So, and then at position 1, our left max would be 1. And then since if we look here, we've descended 1 unit, and since we're lower than the left peak, then we can safely add 1 unit of water. And then when we get to this 2, right, as we're iterating across with, like I say, a left pointer, we can say the new left max is now 2, right? So then when we descend below, we can add 1 unit of water or add 2 units of water because we're at or less than the left peak. Now you're probably thinking, well, how can you guarantee the right side? Like what if you have like, say, a bunch of squares and then it just goes nowhere and there's no right boundary? What we can do is that while we're iterating across from the left, we can also iterate from the right, and we can calculate what the maximum right boundary is. And we can base off how we iterate based on whether the right max is lower or less than or equal to the left max. So let me explain this, right? So basically, let's say we're moving from the left to the right and moving from the right to the left. What if we say we only want to iterate our, say, left pointer, right, if our left max is less than our right max, right? And if this is less than or equal to, and if this condition is not true, we want to iterate our right pointer. Now, the reason we're thinking about this way is like almost imagine it like we have 2 buckets, right? So we have a left bucket and a right bucket, and we need to capture all the water in these buckets. And then we also need to know when these 2 buckets merge into one big bucket, basically, right? And we basically only want to iterate the smaller bucket first until, or the bucket that's lower before we iterate the bucket that's higher. So, so how do we do this? How do we actually do this? We have to think about like calculating. So for example, the left max would be 0 and the right max would be 1. So therefore, since the right max is higher than the left max, we iterate the left max. And now the left max pointing here, the right max is pointing here, and they're on the same height. So basically what we want to do next is then, okay, let's iterate the left pointer across. And then we see there's water and it's left than the left max. So at this point, we guarantee that this has to be water, right? Then what happens is that we iterate and we see, oh, there's a block of 2. So this is our new left max. Now, since the left max is greater than the right max, we're going to iterate the right across. So now the right max is pointing here. And since we've ascended and not descended, there's no water in this instance, right? Then, since the right is the same as the left, we iterate the left. So the left pointer is here. And now we're going to add 1 water unit. So it's basically how you calculate that water unit is basically the left max minus that current value. So this current value at this position is 1, right? And the current left max is value 2. So to get the water, you just go 2 minus 1, or left max minus the left, whatever the left point is pointing at. Okay, then you do the same here. You add 2 units of water, and you go here, you add 1 unit of water. And then obviously you find the peak here, right, which is the left max. which also happens to be the global max. And then obviously you iterate the right pointer here. And since you're descending, you add the water unit here, and then you increment here. And then eventually what happens is that you can end when the left and the right pointer cross over because you've explored the entire graph. So we would come up with an answer of 6, which would be the total water units, which would be accurate, and it would also execute in n time. Actually, we understand the concept of the solution. We're going to actually start executing this in code. So we'll just say n equals the height, the length of the array. And we're going to say if n is less than 3, right? Then we just return 0 because there's no buckets basically because you have 2 columns, so there's no way there's any water. Then what we're going to do is we're going to set up some left and right pointers, and we're also going to set up our current max. We're going to say the max left is going to be whatever's at height 0, and we're going to say the max right is going to be what is at height n minus 1. So then we're going to say is while left is less than right. What we're going to do is basically say, okay, if the max left is less than or equal to the max right, then basically what we want to do, also we need a maybe the water is going to be 0. So then we're going to say if the max left is less than or equal to the max right, then what we're going to do is basically increment our left pointer. Yep, and then basically what we're going to do is going to say the water equals the max L, the max left, which is and then minus the height, which is at L, basically. So for example, if we're going left to right and we see the first block, we'd update the max L and increment the left pointer. So then we're going to say we also want to update the max L to be the max of the L and the height. So the height L and the max L. Yep, and then we're going to do that. And then we're going to do the same else. We'll increment we'll decrement the right pointer. We'll say max right equals the max R, height R. And then we're going to say water equals max right minus height right. And then we simply return the water. So check this. Water. Oh, water plus equals. Water plus equals. Run this. Okay, so height equals that. It's going to debug. Max L, water plus equals height max L. Stat, so that's fine. Else R minus equals 1. Max R. Oh, left, my mistake. The right pointer should be set to n minus 1. Not 0. Yep, there you go. Now if we run this, we submit it, and we get the solution.